Please welcome Vlad and talking about how to talk to your knowledge graphs. All right.
Okay. You start? Let me see. Sorry. Okay, here we go. Okay, so my name is Vlad, and this is talk about, it's actually a continuation of the talk, there was one in January by Griffin. Is Griffin here? No. So he presented how you talk to knowledge graphs with LLM. This is a different take on the same. I was kind of grilling him on the whole thing. He was asking me, and this is one of the reasons this talk exists. Okay, so why? So it's a talk about the SPARQL-TOOL. I developed it in December maybe. And so why did I even do that? So a little bit about me. So I'm a lead software architect at the Arsenal Bauerns and during daytime. And during daytime I deal with a lot of data. So we work on the fermentation. So each one of our machines generates a gig of data a day, and we're trying to get like 100. So like a lot of data. At nighttime, I work on my PhD thesis, and I also do lots of side projects for the community and just for my own personal kind of things. So this particular tool, that's one of my, it's kind of related to my PhD and to the side project that has nothing to do with Arsenal Bauerns. I'm trying to bring the SPARQL in there. Everybody's just so busy, but I'm going to talk about problems with the SPARQL and the things. So I'm going to ask you a question. So I would have asked it, so like maybe 6 years ago, that I would not even think about asking this question. 2 years ago, I would ask it differently. So this year, I would ask a question. Did any of you never used anything like ChatGPT, any agent, ChatGPT, Claude, DeepSeek? Everybody used one, so okay. Okay, good. So if you talk to people and there is lots of criticism about this generative AI. The agents, they say there are the problems, right? And no problems, there is hallucination, which I don't really think it's a problem. Sometimes it's good, because if you need to do creative work, you do want to have, it's not hallucination, it's basically inventing things that don't exist, right? So if you want to write like a mystery novel, you don't want to rehash what exists, you do want creative output. But if you work on something very formal specific, like if you work on your fermentation process optimization, you don't want to invent any facts. So that's one problem. Another one, so it's very expensive to build the LLM, large language models. These are the things that behind these chatbots. It's very expensive, takes very long time. So most of the models, they build from the public data sets, general knowledge, and the knowledge cutoff is from 6 months to a year. So when you're talking to recent events, that model does not know what happened last year. And the worst thing in my when I use it, it's these models, they train on public knowledge, but if you want to get the most valuable answer to your question, so it depends on two things. It depends on the quality of your question and the availability of the data. So quality of the question, it's up to you to ask the correct questions. But availability of the data, even if you ask the ever bestest question ever, the model, if it doesn't have data, it won't be able to give you a good answer. So these are proposed solutions that existed. If you come from machine learning, like traditional machine learning people, they like to fine-tune or rebuild new models, right? They say this model is no good, let's just retrain this model and make it a better model, right? So that's actually legit things, but you don't want to always do it. Another technique, it came, I don't know, 3 years ago maybe, it's called RAG, Retrieval Augmented Generation. So the way it basically, there are different ways to do it, but all boil down to the same thing. It's that when you agent sees the question, first thing is it does, it actually says, hey, can I get some data from somewhere to answer it, to improve the answer. And then when it gets the data, it just sticks it to the prompt, and that goes to model, answer comes out. So there are 3 different ways. There are probably more, but these are the popular ways, at least I'm aware of, from top of my head. So one thing you can just search. That's if you ever use the Claude Code, that's what it does all the time when it works on code base. Every time you ask it to do something, it just does, and that's what the Griffin showed last time, it just does the most recent best way to do it. It's a tool called grep grep. It's very fast grep. It just goes and like searches for keywords. That gets you like the data from the local things. Another one is vector embeddings. So this is also so the search is out of scope for this talk. There would be a little bit search I'll show you. Another one is vector embeddings. That one is like it's out of scope, but it's basically taken your question and converting it to a bunch of numbers, going to the database, looking up what kind of like paragraphs, like match this now close to these numbers, and like fetch these paragraphs taken apart. And the third way that one is actually in the scope for this talk, it's the knowledge graphs. So knowledge graphs are structured, and so you ask specific queries, like, so for example, if I want to, like if I'm asking a question about baklava, like that the query goes to knowledge graph and says, hey, what do you know specifically about baklava? And whatever comes out, that goes in the prompt. And so they're all very structurable, they queryable, so they usually leave like the, you can have knowledge graph in a relational database, or even in a text file. But and actually Griffin showed that like you can just have a bunch of markdown files and like grep them, right? But you need to have a structure. So like as opposed to like just searching random strings, like the knowledge graphs, they graphs, and anybody doesn't know what graph is. Okay, everybody knows what the graph is. Okay. Yeah. So like they're structured and they have to be able to be machine readable. So there are two different camps in knowledge graph community. They all hate each other. There are property graphs and there are RDF graphs. And I'll show the differences. So the property graphs, it's what Neo4j gives you, and they all go around everybody and says this is the only way to build graph. And there is RDF graphs that sort of comes from, it's actually, they come from inventor of the World Wide Web, from Tim Berners-Lee. That was his vision of Web 2.0, and they are superstructures, and they have very, I'll show next slide like what the difference is. But these are two different camps and they are different engines. So like an interesting, there is one called Amazon Neptune. It actually can do both. But the problem is it can do both. But when you create your database, you have to select which type of graph you want to use. Like so, you can use the same agent for like either way like graph, but the graph you're building has to be, you have to choose it. And that is basically shows what the difference between two types of graphs. So property graphs, they more like your kind of Python dictionaries. Like, so you can just have any kind of node. Like you can have node Alice and Bob. Actually, in both of those, you have node for Alice and Bob. And into node Alice, you can put any kind of properties you want. It's like exactly like Python dictionary. You can just say like Alice is an engineer, like you can say Bob is a designer. One thing is what's on that slide, you can tell it's AI generated. This is something you never ever do when you're doing the knowledge graph. Doesn't matter if you're building a property graph or you're building RDF graph. So anybody can spot what the problem is. Like it exists on both of those. There is one property. Nobody, so there is an entity, it says age story. That the reason why you would never put it in the knowledge graph is because today is 2026, like in 2027 that information is going to be incorrect. So you never put if anybody is alive, anybody, like whatever anybody's age, anything changes. So the way to record the age, you put the birth date, like, and then you compute them. In the status, usually how Wikipedia does it for them, they have a graph called DBpedia. They put a birth date and a date and a death date. So if somebody doesn't have a death date, you can presume they are alive. And this is like one thing you never do. But you can see like the way you build the graphs, like so the property graph, they are like a Python dictionaries, and RDF graphs, you can only have the built of something called triples. Triples are, it's like a three values, they are subject, verb, and object. And everything is expressed. So like you have a subject that would be Alice or Bob, the subjects. And for example, at the Alice, it has the two verbs attached to it. It has a role and it has an age. Like so, the verb is like Actually, they call it the subject-predicate object because, yeah, the predicate is better word than the verb. So you basically, there is very defined thing in the system that says there is a predicate called age, and age has to be like an integer and has to be range like from, it has to be positive, things like that. So the RDF graphs are super controlled. They have classes. So it's kind of like the way to think of them is you think you sort of Python free, like before Pydantic and everything, just free dictionaries, and you think enterprise Java, like where like you step out of like the realm, like everything has like tightly controlled. You step out, you get shot. So that's as RDF graphs. And I'm not going to go in like difference. It's good in another talk, like like which one is better than that. So RDF has the whole ecosystem there. I mean, there is actually the RDF data model. There is OWL, so like it's an ontology. So this whole RDF comes from like academia. There is the whole building in MIT dedicated to like everybody is basically work on RDF there. So what is OWL? It's an ontology language. What is ontology? It's basically it's how would you describe your like the model of your world, like so in your world you can have people, for example, people have age, like so all these possible properties, classes, relationship. That's when I said the age has to be positive. That part of ontology, but ontology does not have data. It's just the way you like describe. So if you think it's your, if you go back to Java or Pydantic, that's your class kind of structure. And this, so there are triple stores and database engines. They are basically they just engines, like that's where you store your data. And there is a query language called SPARQL. So this is not like to get out when you get away from the stock. You don't need to remember. You just need to sort of like know these terms exist. You don't need to like learn anything besides this looks right about them. So there's a problem with RDF, right? Because that actually has been created in 1999 or 1998. And it has not caught up much because outside of academia, very large manufacturing, like I think GE uses it, like very large companies. I think like some stock market people use it, and a lot of European bureaucrats. Like so, if you want to get EU data, a lot of it comes as the RDF, and the reason is because it's very steep learning curve. You almost need to do like people did PhD in RDF. Like. And there is conferences, like papers, so like it's a whole thing. You can still, this conference is still going around. And that's one of the problems to actually read anything about RDF. You have to give $100 to Springer to get like last year's proceedings. Right? So if you work for some place that has Springer subscription, then you can like, get all of them. And ontologies, yeah, so that's super complex. But last couple years, we got this LLM models, and they build these LLM models. LLM models actually, they do have PhDs in the RDF, like, apparently. So, and what you can do, you can actually ask the LLM, and that's what I was doing 2 years ago. I would just basically ask a question in like natural, like English language, and ask, hey, give me a SPARQL query for like this. I want to answer this question, right? And it will like chug around for a few, like 20, 30 seconds, give me a query, like I would be like something, like I'll show you some queries that come out of LLMs. They'll give you instant headache, even if you've seen LLM, I mean, SPARQL queries, but you just stick an engine, you get what you need. And so, but cut and pasting is like not very productive way to do it, like, so that's why I sort of built this tool. It's like, you see where the whole thing going. So what the SPARQL is tool, it's the democratization of the RDF for like everybody. It has like three pieces in there. It has the skill and agent and CLI tools. Like if you, I think it started from Claude, but now it's spreading. This is the replacement of MCPs. But you can actually, if somebody really needs MCP, you can either like make yourself. You can ask me nicely. I can make an MCP for you, like because MCP is kind of going down. And actually, you can also use the tool like, just if you want to query things. So let me start with some demos. Like so, this is the talk part is pretty much over, so I can just show. Yes. Yes. Okay. So demo. So this is this my usual agent. This is the agent that I normally use for my daily work. It's a Claude code. it's kind of like ChatGPT, but it works in the terminal, right? And this is nothing. This is not using SPARQL-TOOL. This is raw. You can repeat this exercise yourself. You just go to ChatGPT. You can launch the code. So you have to launch code in empty directory. Just create empty directory. And if you have any customization on your code, like delete all of it, disable, rename it. This is completely raw code without anything like attached to it. So basically, actually we kind of, I mean, you can see interaction there, like I did Betty Crocker thing. So everything pre-recorded. So like I just said hello. This is like on the top it basically complains about the API keys, but then I say hello, and I say let's talk about Cambridge, and I ask it like, hey, let's find some people named Gilbert. So which people named Gilbert connected to the Cambridge institutions. How are we doing on time actually? Okay, good. Okay, so okay, one thing it did. Okay, so like we missed it, but if you let me see how you go back. Okay, I guess you can press F if you scroll back a little bit. So I ask, if you've seen the question specifically, I ask how many people with the first name Gilbert are connected to MIT institutions. You see what came out, it says like everybody is the last name Gilbert. And why did it happen? Because the Claude is kind of like it tries to be smart, and it tried to do this web search thing, right? But the web search thing, it actually says famous people named Gilbert in Harvard, MIT, Cambridge, Massachusetts. But problem is it did not say the first name. And that's a semantic loss, basically, when you use like agents by itself, like because it did the web search, it did find the things, but that was very important because like the question was specifically how many people with first name Gilbert have the thing. Oops. I get it going again. Okay. So I have to clarify it already. Like my first question, I did not get the right answer, but then it basically says, okay, I found you your Gilberts, like with the first name, so there is Gilbert Lewis, Gilbert Strong. I asked it, hey, you missed one of the Gilberts, because it did the web search, it probably Googled, and that's what it found. So it says like, okay, sorry, but it says, yes, there is Gilbert Stock. American just anyway, so let's see what it knows about Gilbert Strong. And now it goes to exact knowledge, and I don't know where they got this data from, but for example, it does not talk about the Gilbert Strong's PhD student, but it did get the things. And ask like, who are his students? And the answer is basically, so they coded this like the guardrails. I don't know if you know the guts of the agent systems. There are some called guardrails, and it basically it understands, so like it's, it does not have any knowledge and it does not want to generate any. So it tries away because there was so much outcry about hallucinations. The recent crop of the models basically try to avoid them, and it basically tells you go away. And it's probably something in the Claude code. Okay, so now like if anybody doesn't know what Kevin Bacon algorithm is, so basically we want to use the Bacon algorithm, and we see how Gilbert Strong is connected to the baklava. And this is like that Griffin told me, it's a game, and that's what you can use your SPARQL-TOOL is to cheat on that game. There is a Wikipedia game, somebody gives you two like Wikipedia articles, and you need to find the shortest path between them. And we can actually fast forward that almost to the end because it's, okay, so one thing it does, and it's a problem, is so there was a whole uproar from the website owners because they all have ads and everything, that the website traffic from people dropped like dramatically. And they, now everybody is basically trying to detect, and because the reason it's dropped, everybody talk, like majority of the people talk to the ChatGPTs and whatever agents. Nobody goes to websites anymore, and like they basically advertisements, dollars, everything like go down. So they say, okay, now let's fight the agents. Like we're going to prevent the agents. Like So the Claude is actually smart enough. It says like it doesn't know that information. Oh, and actually it does. Because we ask it to go to Wikipedia, it tries to go to Wikipedia. And the Wikipedia basically tells the Claude, go away. Right? So it cannot go to Wikipedia, it tries to recover, and it starts doing web searches. Right? And you can see what the problem would be. Oops. Okay, so we're still going here. And it's almost done. And it did find something, right? Okay, oops. Let me see. Okay, it didn't make it went to this one. Sorry. Okay, messed it up. So we can just scroll back there, and it's right there. Okay, so it actually found the link. So because oh wait a second. Oh, you know what? I gave something away first because you were the first one. Okay, you got the spoiler there. Because it's actually my first time using this tool, and looking at there. Okay, and then just scroll back a little bit. I think it only works on the full screen. Scroll back. Let's see. So it basically did found, it says there is 7 hubs essentially. So it's here. I think the keystrokes are not getting there. No, so basically at the top, like the first 3, it's, let me see if I can spell it. No, okay. So the hubs basically, so Gilbert Shrunk is known for linear algebra. Linear algebra is type of algebra. Algebra was invented by Al-Khwarizmi. Al-Khwarizmi was used to work in Baghdad a lot. Baghdad was taken over by Ottoman Empire, and Ottoman Empire, like, it's very known for baklava. So that's the 7 hubs. That's the best it could do, like. And I did not verify it because when you talk to the agent, it could not go to Wikipedia, so you might not be able to. This one would probably work. A lot of times when I was making this talk, lots of times it was creating the part that this pages on Wikipedia, like the links on Wikipedia, do not exist. Okay, so the same thing, you actually saw the end of it, you got the spoiler, but it's exactly how would you use the SPARQL tool. So to use the SPARQL tool, there is a repo I'm going to share at the end of the talk, but basically you launch it in the repo just have like a very few, like it has a skill and the agent in there installed. And now you notice the difference. When you say hello, like what it actually does, it goes and verifies. So it's exactly the same scenario, like, but it's just like with the tool installed. When you say hello, it goes, verifies that SPARQL agent exists, it bootstraps it, and then we can kind of keep talking. So today we'll talk about the same, it's exactly the same interaction. So we talk about, oops, well, I'm just trying to, so for the sake of time, to speed it up a little bit. And probably mess it up. Yeah, so today I have the same thing. So today we're going to talk about Cambridge, Massachusetts, but now I give a little things. We say, like what the DBpedia is, it's extraction, they do it every, I think, 6 months or something periodically. They extract the Wikipedia data and Wikipedia collaborates with them and they publish it as RDF knowledge graph. Right? So that's why if you want to play with knowledge graphs, that one of like it's super, it's pretty large, but it's not something that you need megawatts of power to use it. So, and the thing is like, so how the tool works, like when you talk to it, there was something called ontologies. So when you say you want to talk about Cambridge, Massachusetts, we want to use the DBpedia graph, it goes and discovers then like what ontologies actually exist. And the reason for that, because ontologies define classes, define classes properties, like all kind of constraints. And if the agent knows about the ontology, it can make much better queries. And that's actually, that's when the discovery has finished. Let me stop it. Actually, we can talk about its types. So basically, it goes there. It says that it found 3 ontologies. What is it? 483 classes. There is 200 properties. So I'm asking exactly the same question. And you see what happens. Difference now. It doesn't go like search the web. It doesn't go. It goes straight to database. And you'll see the query and what happens. Let me just jump around because it's probably better. Okay, so this is a good query. So now this is how SPARQL queries look like. So we asked it the same question, and it's people in Massachusetts connected to institutions in Massachusetts, right? So it basically, we said that there is a node for Cambridge, Massachusetts in DBpedia. It's because there are some things like locations. So it says we're only looking, this is a fixed in database. So what it does, it basically, it cuts your graph and only the nodes connected to the Cambridge, Massachusetts specifically have this, are going to be part of the query. And it's basically, it's one big union. One thing, it's actually, I mean, it's the LLM stuff, but it always does it. It does not search for Gilbert specifically, it searches for the, any name that starts with Gilbert. And you see like it will be like interesting things there. So the one I'm showing, so when you actually talk to the agent, this is debug little like hatch in there. When you talk to the agents, you do not see the queries. It kind of just does it. Like you see this little like, you only see this little bashes there. Like so when it runs the SPARQL-TOOL, but it's basically, it uses the tools. For some reason, all my interactions always take 2 minutes. Like, but basically, and one thing is, it's kind of flashes there. One thing, it was kind of my fault in the questions that I said how many people. So the result of the queries is actually going to be the count, right? And so it kind of runs. Okay, and okay, I'm not going to show it there, but basically it says like there is, it just gave a table with the count. It says there is like 2 people from MIT, like 3 people from Harvard Law School, and there is like other one, right? I said, okay, let's look at Gilbert's from MIT and the things. So when you ask these questions, it does not search the web, it does not use the internal knowledge, it always goes to the database and not asks. And so for that reason, so your sort of quality of your answers depends exactly what you need in the database. So like there is one problem, you still get the knowledge gap because the DBpedia is does not publish like on real time, right? But one thing you see, like what it found, it also found not only Gilbert's, it's also found Gilberto Teodoro, because when it was running the queries, it was not looking for Gilbert, it was looking for first name starting with Gilbert. So that's fine. And let's do the things like I'm going to, okay. Yeah, so one thing is actually, you can see like it can instantly answer because the DBpedia has the whole academic genealogy in there. You can see who the Gilbert Schrank's famous graduate students are. Like it was like straight from the database. And we're doing the same thing. We are asking how is the Gilbert Schrank connected to Baklava. And remember how many hops was that originally? Was 7 hops. Like. And so if you go now, so one thing with the Kevin Bacon and its this tool, it's actually very hard to encode Kevin Bacon algorithm in the SPARQL. Like with the property graph, it's trivial. But the best way to like do it is basically do the Google search. There is like somebody's Python script that does it, and just use that because I mean it's not very big. It's like 200 line script, but it's with this agent, like, so I did not even code it, the agent just does it. And if you look at what it did, it's at the end. It's actually, so it counted 3 hops because it was counting the Gilbert Schrank itself as a hop. I do not count. But actually you can get from Gilbert Schrank to Baklava in 3 clicks. So the first click, because he has a bachelor degree, Jordan is one of the countries that also gives out bachelor degrees, and and Jordan is also, Baklava is very big in Jordan. So if you go in Wikipedia, there is like on that page, it's. I think I might have it. Hold on, do I have it? I don't. Okay, we'll keep going because just for the sake of time. Okay, so that was a fun thing with Wikipedia, but I mean, if you work in biotech and everything, you should never go to Wikipedia for anything. So there is another. Very big, I was talking like lots of people are aware. There is a service, it's run by Swiss, I think it's Swiss Bioinformatics Institute. It's a huge international organization because it started as Swiss, but and there was something called Swiss prod, but now it's called Uniprod because it's a huge international collaboration. What they do, they collect and publish information about proteins. So if you need to know anything about protein, that it's not your private proprietary protein, it's a public, well-known protein, you go to Uniprod. So I started, like every single interaction with this tool, actually it's not. This is very, when I work with it, I kind of built it in a very complex workflows. Usually my week looks like I start like 3 agents on Monday, and the agents go chug around for like 3-4 days. Like this morning they came up and have to go look tomorrow like what the agents came up with. So that's tool that sits very deep in the workflows. Like, and so it's actually, this is the ginormous data set, so it takes a long time to bootstrap it actually. Even, like. So when it goes here, and when we actually start doing things, let's see that we jump around. Please focus. Because with this tool you need to be in full screen for that. Let me see what you had for interactions here. Bootstrapped. Okay. Yeah. Okay. That's actually what it found. It found. Yeah. So now you can ask questions about, for example. So this is more like bioinformatics type of questions. So which proteins are associated with Alzheimer's disease? And when I was doing this talk, doing this like captures yesterday, I actually went to look at the literature. The answer is completely legit, like, because like you can do it on the slides, but it can also give you links like to the articles and literature, like, so anything is yeah. And this let me see if I can stop it. But basically, yeah. So these are popular Alzheimer's proteins. I was just looking. There is lots of like startups, biotechs, and everything. They work exactly in this protein space. Like, so this is legit. Another thing, so this is actually very hard kind of questions. What proteins insulin interact with? That is exactly running Kevin Bacon. It's not because there is no information. You have to kind of go like through the protein-protein interaction networks and find like what's the popular done in the insulin and yeah. And like when you look the queries, like they become bizarre basically. And the so Kevin Bacon takes, it's kind of, to run it on very large graphs, it takes a long time essentially. So you see it sped up, it's actually was doing it for like 6 minutes. But that's actually pretty good. If you can get the any random protein or any random small molecule and you get your accurate answer in 6 minutes, it's not actually that bad. And these are basically, it says, this is the known proteins that interact with insulin. And another thing is, because we are not going to the random people, we go into very respected things. It actually says all the data it showed above, it actually gives you the table. It's actually, it extracted it from this INAC database. And INAC database, everything there, because Uniprot has kind of 2 big data sets. It has not that many, it's probably 400,000 proteins that we have hand curated. There was a like PhD grad or postdoc or something. They actually looked at that protein. They curated everything. They verified everything legit and like said yes. And this goes to very high quality data set. And it has another data set. It's called Tremble, and they just mine like literature. They use machine like it's been around for a while, so they use machine learning. They just extract automatically information. And that one, I think I was looking, it has like 800 million proteins or something. But when you query Uniprot, you need to know like what, which data set it came from. And it's actually everything labeled. So like that's advantage RDF SPARQL. When you get information, you know exactly where it came from. You can go like it has provenance records. You can go to articles and everything. And it says like everything that it gave you, it's actually been validated in the lab, and there is direct experimental like evidence. So you do know like how maybe that graduate student who was doing experiment, maybe he had a hangover and the reviewers kind of overlooked it, were kind of busy. So like if somebody does the experiment, it doesn't mean it's absolutely like true, but it's at least like there was like 2 or 3 people involved in the coaching. Like, and so this is a good, but when you work actually in the company, Uniprot is great, and Campbell and gene ontologies, but lots of pharma, biotechs, they're very secretive, and they have information they don't publicize it, or sometimes they find something that's general public doesn't know about, and they keep it secret. So to get real things, you want to talk to your own data, and this is another demo. So for that, how many people do know about the Pokemon? So okay, maybe explain. So when I started the whole thing with so I started a project called LinkML. It has nothing to do with it, but has known with the knowledge graphs. I needed knowledge graph to work on. You cannot work with DBpedia and Uniprot, they humongous, and all the other graphs, they very smallish and they kind of toy, they're like Alice knows Bobs and Bob knows George. So then I found this community graph, it's called Pokemon, it's about the Pokemon. So that's actually good because it has probably 100,000 entries in there. So it's something you can put on your laptop without any, you can put it on your phone without straining it. But at the same time, it's 100,000, so you cannot plot that graph. It's going to break any visualization library because it's, yeah. So the one thing I did with the Pokemon, I actually created, so how I created it's also to scope by, you can talk to me, to refresh. I created a little addition to the Pokemon. So when I work with the Pokemon data set, you can actually see the same bootstraps. You can see the same, which one? Yeah, I'm on Pokemon. And actually full screen it. Yeah, so it's actually, let me see if I can put it. Okay, yeah, exactly. So you see it here. So there was, it's a standard graph. So it's basically, it's a combination of the graph, the Pokemon graph of you can see there a few thousand nodes. It has species. It's a standard. I think it's some generations of Pokemon. Because when after a year working with Pokemon, I know a lot more about them than before I started it. So there are some code generations basically. And yeah, so it was I skipped that interaction. There was the same question I just said. We're going to talk about Pokemon. We're going to use Pokemon graph. That's what happened. Okay. And the question might be at the PyData Boston meeting, what Pokemons can we find in here? Okay, let me full screen it. Actually, it was full screen. Okay. So it's again so every single thing here so that I was kind of dropping in debug. You can see the queries. So it kind of goes through. Okay, and these are the these are types. So this is not the species. This is a type of Pokemons. You get what you get: Bayesian, you get vectorized, you get stochastic Pokemon. So and yeah, and then you can sort of say okay. By the way, so that data about the this, all the Pokemon data is in public. There are links at the end of this presentation. Okay, so let's pick one random Pokemon from each type and just show which, because somebody said Bayesian Pokemon. We'll see what the Bayesian Pokemon is Okay, so so we almost done that. Okay, so I will start scrolling up. So let me actually start jumping and opening. Okay, so oops. So you can actually see. So one of the Pokemon, there is a vectorized Pokemon. It's his name is Matplotlib, and it's a figure eight. And there was another one. I think there was the Julianus. It's the Julia Pokemon. Who uses Julia? Nobody. And you can actually see, you can see it in performance. So what if you make? So I was basically asking, if you make them fight, and if you have 4 random fights, and who's gonna what's the statistics of this Pokemon? So if you don't know about Pokemons, they have skills and abilities, and they fight each other, and they use and so that's going on. No, they only know then if this Pokemon has skill in Markdown, probably not, but okay, so it actually got the stats, and this is the outcome of it. It basically, so the problem with Julia, if nobody uses Julia, that's absolutely true. The problem is the Julianus always loses because the Julia Pokemon, it has what? It has 47. It has 47 seconds. It has to JIT compile itself before it actually can do anything. And by the time it JIT compiles itself, it gets obliterated. Right, and then so then more things. It's oh yeah, and so now I did another thing. So which Pokemon knows Fortran? Like so, and it actually goes, and there are actually more of them, and there is one of them. It's going to be called Fortranus, like, and then so it kind of goes. Okay, so there was LLM, there was a PyTorch, I think, or yeah. So there are different like Pokemons you can see there. So there is a Fortranus that knows Fortran, and another one. It's called Transformius. It does the CUDA like things like. So what if you make them fight? And you can see the outcome of that fight because we want to kind of shorten time. Oops, we'll stop right here. And so, and basically Fortranus is it's very fast. It has a skill of go-to statement, and it confuses the other Pokemon. But the Transformers always wins. I think there is 3-1 basically. Transformers is basically it has immense power and it's always overpowered. So that's what you can do. Like there is no the only thing that was made this possible is just standard Pokemon knowledge graph, everything out of the box. Like you can check it out. There is very few things. So there is the tool. Oh, and actually, yeah, and there's one thing you can just use the tool by itself. And it's probably boring. So you can. Oops. Yeah, you can use the tool by itself, and actually you can go pick on the tables if you're interested. So when you use it, so there was the talk by Griffin. This is very summary. Like so, the only reason when you want to use the idea of graphs, if somebody taken time to develop very good ontology. So if you work with protein, yes. Like if you work with the EU bureaucracy, yes. Like if you have some kind of domain, you never there is no RDF graph exists. You either need to hire 3 postdocs and give them 4 years to work on the things, or you're going to get very crappy ontology. With Markdown, you can just basically start doing them. There is not going to be much structure. It's everything ad hoc, but you can just start one today. I usually, when I create a lot of my, yeah. So if there is public ontology exists and it's a new domain, of course, yeah, that's how you map your data. I mean, we can talk about that's a good question, but we can talk after this, how you map the data. Yeah, but if ontology doesn't exist, that's don't even try. And here are some, because this group is big on QR codes, so you can get the QR codes. So the first one is to get the actual tool. It's probably useless, because the way to install it, right now you can write to me if you really ask me nicely, I'll do it. Right now the only way to install it is through the homebrew. You just tap, or I have a private tab. If I get 30 likes on that GitHub repo, I can publish it on the full one. Okay. Oh, you get 4.4? Oh, I'll fix it. It's probably on the demo repo, but other ones. Okay. Save QR code, refresh it. It's probably private, right? And the other ones, that's my LinkedIn profile. So if you have questions, everything. And if you have questions, that's a future plan. So I'm just going to push it to marketplace and optimize it. So it's not very optimal right now, but it works. So we have minutes for questions. Mm-hmm.
Basically, there are some tools which are robots around the relational data.
Mm-hmm.
So kind of if you have a public ontology, so public graph.
If you, but it's not the relational data, so it's a wrapper.
You use the wrapper around the relational data. So you have a regular data, and basically the process is to map
the relational data to ontology. That doesn't work very well, because I think somebody, either this talk or recently, I think there was the last month talk. Relational databases are not very semantically rich. I mean, they do have relationship, and they do have things defined. Ontologies are a lot more. They have a hierarchical structures. they kind of link to the other one. So of course you can create ontology from the relational data. I mean, you will get classes and properties and everything. But it's not going to be very good ontology. Because it's going to be semantically poor, basically. That's the reason. And yeah. No, pgvector is just the embeddings, like it has nothing to do with formal semantic. Right. And there is a reason I don't use pgvector, I use ChromaDB, but it's the same thing, right? But it's okay. No, I was not. It was interaction. It's just a pointer, like this protein. It's a protein-protein interaction. It's doing exactly that whole Kevin Bacon on Wikipedia, how we did the like Gilbert and baklava. It's exactly what is in a protein-protein interaction network. Like when you start spreading it from insulin, like what do you get? Okay. Maybe like for the time we can talk after this. Like I'd be happy to like talk about this.
Yeah. We're gonna have to call it there. But
Yeah, I mean I'll be around like so if it's.
Thanks so much.
Okay.
Can I swap in there? Do you mind? I'm gonna put this up at the very end, just in